Greetings! In the previous video we covered the security aspect when developing microservices in Kubernetes environments. To strengthen security, we moved sensitive data to a secured namespace and pulled this data safely using the external secrets operator. But this is the basic case of using the ESO. As a more advanced and reliable solution, you can utilize services like HashiCorp Vault, AWS Parameter Store, or any other secure vault you prefer. As promised, in this video we will practice integrating the external secrets operator with AWS Parameter Store. This service allows you to store configuration data in encrypted format in a safe place. The overall scheme of the process is the following. The external secrets operator reads the secret store configuration in the application namespace. It obtains the provider, AWS Parameter Store, region, and the service account in use. The ESO controller uses the service account specified in the secret store. It presents that identity like a passport to AWS in the given region. AWS checks that the role's trust policy allows the service account, then that the role has permission to read from Parameter Store. Parameter Store then decrypts the value and returns it to the operator. From the external secret resource, ESO knows which parameter to fetch and how to map it into a Kubernetes secret. It then creates or updates that secret in the application namespace. The application then uses this Kubernetes secret for its needs. Think of it as making a local copy of a file stored in a cloud drive. In this case, the sync client has credentials to access the cloud storage such as username, password, and MFA. Good cloud storage keeps your data encrypted and decrypts it on demand. When data in the cloud is updated, it prompts you to synchronize your local copy. Now that we know how ESO and Parameter Store integration works, let's set up this integration in Kubernetes CI. First of all, we need the application that will use the secured data. In our case, this application will be deployed using Kubernetes CI. We won't create a codebase and deployment flow in this tutorial. Instead, we will add the links to the corresponding videos we recorded earlier. For this guide, ensure you have a codebase and a deployment flow with an environment inside it. The target namespace for the application is automatically created by the platform when creating an environment. You can see it here. Now, let's open the application's repository. The application deployment has been configured to utilize the Mongo secret. The external secrets usage application is going to connect to the Mongo database. To establish connection, it needs to specify credentials such as username and password. This data will be written to a Kubernetes secret, which will be created by following the specifications of the external secret resource. Here we use data from and extract. ESO fetches the entire parameter from AWS Parameter Store. The parameter value must be JSON. Each top-level key in that JSON becomes a key in the Kubernetes secret, so we don't list each key in the manifest. If you add new keys in Parameter Store, they appear in the secret automatically. The keys in the JSON should match what application expects, for example, Mongo username and Mongo password. The operator will use this secret store to access Parameter Store. To access this parameter, the operator will refer to the following secret store resource. This is the configuration file for the secret store resource. Here we can see that it refers to the AWS provider and the Parameter Store service in the Europe Central 1 region. To authenticate with the service, the Secret Manager service account is used. And regarding the service account, we can see that it's associated with the AWS IAM role called EOS get params. Let's view this IAM role in the AWS console. The EOS get params role contains a policy and a trusted entity. In the Trust Relationships tab, we defined a policy that allows the service account called Secret Manager in the application namespace of the target cluster to assume this role. So the role is allowed to get parameters from the Parameter Store. It grants the getParameter action for all parameters whose names start with EDP. We also created a parameter which contains the credentials for the Mongo database. We recommend creating parameters of the secure string type. Okay, great. Now that we have everything prepared, let's proceed with deploying the application. Navigate to the portal, Deployments, Environment, and configure your deployment. We can observe the pipeline completion status in the Pipelines tab. The pipeline is completed successfully. Now we can verify the deployment configuration. Open the Argo CD application. As we can see, the resources that we added to the application, such as Secret Store, External Secret, and Service Account, are created. Now we can check how they were created. We need to make sure that the secret data is created properly. Navigate to the terminal. First, we need to check the Secret Store resource. It will tell us if the ESO managed to connect to the Parameter Store. The status valid message indicates that the Secret Store is working as expected. Now let's look at the status of the External Secret resource. Status Secret synced. Good. Now let's check whether it created a secret. Data shows 2, so it contains 2 keys as expected. Let's list them. Indeed, it stores the Mongo username and Mongo password keys. Let's read this data in a pod. To do that, we need a pod name first. Now let's check the environment variables in the pod. Yes, this is the exact data we put in the parameter in the AWS Parameter Store service. In this tutorial, we set up an IAM role for the service account with the necessary permissions and trust relationships. We also configured the external secrets operator to access the required parameter in the AWS Parameter Store using this service. Such integration is a strong security measure. Even if someone gets unauthorized access to your application configuration, they will not be able to read the secret data. They will only see that external secret resources refer to encrypted data in an external store. It also allows you to control who can access the encrypted data in AWS by using the IRSA approach. That's all for today. Subscribe to stay tuned for new guides, and thank you for watching.